Okay, let's get into this. You've brought us something today that really cuts through some of the recent noise. You know, these big headlines popping up everywhere claiming vitamin D is suddenly this anti-aging miracle.
That's exactly it. The source for our deep dive today is a blog post called Behind the Paywall, What the Vitamin D Anti-Aging Study Really Says.
And the author is Dr. Lutz Kraushar. He's got a doctorate in public health, a master's in exercise and nutrition, quite the background. And he writes a Substack called Double Check Doc.
Yeah, the name says it all, doesn't it?
It really does. Sets the stage perfectly for what we're about to do.
And his argument is, well, pretty direct right from the start. He looks at the specific study everyone's talking about, considers the broader evidence on vitamin D, and basically says, look, neither really backs up this huge anti-aging enthusiasm from the media.
So our mission here, kind of mirroring his, is to give you, the listener, a really clear, unbiased look at this study, especially since, as the title says, it was stuck behind a paywall, which isn't fair.
Exactly. It's about empowering you to make a truly informed choice about, say, supplementation based on what the evidence actually shows, not just the headlines.
And he promises something more, too, right? A better alternative for healthy aging.
He does. He suggests a different focus based more on solid evidence.
Excellent.
Yeah.
Okay, let's dive in then. We're going behind those headlines, past the paywall, to see what the research really tells us.
Yeah.
And I think you might find some of this pretty surprising.
All right, let's start at the beginning. The source makes it clear this recent buzz isn't about a brand new trial, but an analysis of an older, much bigger one.
Right, the parent study. Tell us about that one first.
It's called VITAL, that's VITAL, for vitamin D and omega-3 trial. And this was a serious piece of work, like the gold standard, double-blind, placebo-controlled, huge scale.
How huge?
Nearly 26,000 adults in the U.S., men aged 50 and over, women 55 and older.
Wow, 26,000. That's massive. A really significant effort.
It absolutely was. And it ran for a long time, from 2010 to 2018, funded by the NIH, the National Institutes of Health. We're talking like $43 million spent over the years.
Okay.
And the main results. Published in the New England Journal of Medicine. Top tier.
Okay, so a major, expensive, long-running gold standard trial. What was the big question? The primary goal?
The main aim, the reason they did all this, was to see if giving people daily high-dose vitamin D or omega-3s or both could actually prevent the two biggest health threats for older adults. Cancer and cardiovascular disease.
Right, the things we worry most about as we age.
Yeah.
And what did they find specifically for vitamin D regarding those outcomes? Cancer and CVD.
Okay, here's the first really crucial point, and it probably clashes with those recent headlines. The main VITAL trial found that taking high-dose vitamin D every day for about 5 years did not reduce the overall incidence of getting cancer or having major cardiovascular events like heart attacks or strokes.
Wait, really?
Really. Omega-3s didn't show benefit either, by the way.
Hold on. So the biggest, most rigorous study designed specifically to test if vitamin D prevents the major diseases of aging found. It didn't. But now the media is buzzing about it, slowing aging based on the same data source.
Yeah.
That feels like a huge contradiction right off the bat.
It's a massive disconnect, and it really underscores why these large randomized controlled trials like VITAL are so critical. They test causation. You know, observational studies might see that people taking Vitamin D are healthier, but that doesn't mean the VITAL caused it. VITAL asked, does taking the supplement cause better outcomes for cancer and CVD? And the answer for those primary goals was no.
Okay, so VITAL finishes in 2018, finds no effect on cancer or CVD. Why is it suddenly making headlines again now with this anti-aging angle?
Well, that's where the secondary analysis comes in. It's an ancillary study, meaning they went back to the VITAL data, took a subset of participants, and looked at something different. This is what triggered the recent media storm.
The hunt for a positive result, as the author kind of puts it. I guess you can see the temptation, right? After spending $43 million?
Exactly. 8 years, huge investment, primary goals aren't met, you've got this mountain of data, so there's definitely pressure, or at least a strong incentive, to see if anything positive came out of it.
But isn't that risky? Just digging around in data after the fact? I've heard of p-hacking and stuff.
It can be very risky. The author uses this great cycling team analogy. Imagine you coach a team, train them for the Tour de France, they lose. But then you sift through their performance data and find, hey, their average heart rate was lower on climbs. So you announce your training improved cardiac efficiency.
Right. Celebrating a minor finding when you failed the main goal, That's data dredging.
Essentially, yes. Finding a statistically significant result just by searching long enough, which might just be random chance. Now, to be fair, the author notes the Vital researchers did try to legitimize this secondary look.
Oh, so?
They registered it as an ancillary study. There are clinical trial registries where researchers are supposed to lay out their hypothesis and methods before they start analyzing for a specific question. It's meant to prevent fishing expeditions.
Okay, so they did register it. That sounds better. But the author still sounds skeptical.
He does, because even with registration, he argues the finding still carries the, let's say, stigma of being exploratory, something looked at after the main trial failed. It wasn't the primary pre-planned confirmation. And he highlights a specific timing issue with this registration that, well, raises an eyebrow.
Oh, what was the issue?
The registration for this ancillary study, looking at telomeres, happened in 2020. But the ancillary study itself, meaning the collection and initial funding to analyze blood samples taken years earlier during Vital, actually got underway back in 2016.
Hold on, a 4-year gap between starting the work and registering the specific plan for analysis.
Yeah, 4 years. The author acknowledges they did register before the final analysis for this telomere question began. But that long delay between starting the ancillary project and formally registering the specific hypothesis, while it fuels suspicion, did they maybe see some early hints in the data before locking in the plan? He says it leaves this stigma of it being potentially a plan B.
That context is really important. And I like his point that we, the listeners, can actually check these things. You can find the trial registration number in the paper and look it up yourself.
Absolutely. It's a tool for critical thinking.
Okay, so this specific ancillary study looked at a smaller group, about 1,000 people from Vital who live near a study center. And the new outcome was leukocyte telomere length, LTL. Why telomeres? What's the connection to aging?
Right, telomeres. For a while, they were like the big thing in aging research. The easiest analogy is the plastic tip on your shoelace, an aglet. Telomeres are like protective caps on the ends of your chromosomes. They stop the DNA strands from fraying or sticking to each other when cells divide.
Got it. Shoelace tips. Perfect. And aging.
Well, the thing is, every time most cells divide, those telomere caps get a tiny bit shorter. Eventually, they get too short. When that happens, the cell basically stops dividing. It might trigger self-destruction, that's apoptosis, or it enters this state called senescence.
Senescence.
Yeah.
Wasn't that the Geyser cell state the author mentioned?
Exactly. These cells aren't dead, but they're not really working properly anymore. They just hang around, and worse, they start spewing out inflammatory molecules. This creates chronic, low-grade inflammation, which is a major suspect in driving the aging process and many age-related diseases.
Okay, that makes sense. So measuring LTL, the average telomere length in your white blood cells, your leukocytes became a way to try and measure this wear and tear.
Sort of, yeah. The idea was that chronic inflammation and stress, common in aging, make your body produce more leukocytes. Faster production could mean faster telomere shortening in those cells. So average LTL in a blood sample was thought to reflect this systemic stress, acting as a kind of biomarker for biological age.
Okay, I get the concept. But you mentioned the author is pretty skeptical about this study's LTL findings and the hype. Let's go through his reasons. Reason one we've touched on. It's a secondary analysis, registered late, after the main trial failed on its key goals.
Right, that foundational critique.
So let's critique number 2.
This one's maybe the most fundamental. The clinical relevance. The author asks the really critical question. Okay, let's say vitamin D slowed LTL shortening a bit. What does that actually mean in the real world if it didn't prevent cancer or heart disease in the main Vital trial?
So the biomarker changed, but the actual health outcomes didn't. It makes you question the biomarker's importance, doesn't it?
Exactly. Is LTL just a bystander, something that correlates with aging but doesn't drive the diseases? Or is it causal? The source points out this is still debated. We don't definitively know if shorter LTL causes shorter health span. And get this, there's even some evidence linking longer telomeres to higher risk for some cancers.
Wow, that's totally counterintuitive. Really complicates the picture.
It does. Plus, on a practical level, the author notes LTL isn't something you can easily get measured reliably or compare lab to lab to track your personal aging.
Okay, so questionable clinical relevance. What's reason number 3 for skepticism?
Significant loss to follow up. In this LTL sub-study, they started with almost 1,000 people with baseline LTL data, but by year 4, they only had data for about 660. That's a 34% dropout rate.
A third of the participants dropped out. Is that a big deal?
It can be a very big deal. It's called attrition bias. The people who drop out might be different from those who stay maybe less healthy, maybe less likely to stick to the supplement regimen. Even if researchers try to statistically adjust for it, losing that many people can definitely skew the results and potentially make the treatment look better than it is.
Right, another potential flaw. Okay, reason 4 deals with subgroup analyses.
Yeah, this is common. The study authors and then the media highlighted that vitamin D seemed to work better at slowing LTL shortening in healthier subgroups. Younger people, non-smokers, people without obesity or diabetes.
That sounds plausible. Maybe it helps healthy people stay healthy.
It sounds appealing, but here's the catch the author points out. While the LTL change might have been statistically significant within a subgroup, like VD non-smokers versus placebo non-smokers, the difference in the effect between the subgroups, say the magnitude of the VD effect in smokers compared to the magnitude of the effect in non-smokers, was not statistically significant.
So the vitamin D wasn't actually proven to work better in the healthy groups compared to the less healthy ones.
Exactly. The author basically says that makes the whole subgroup discussion kind of moot. It suggests the overall effect is weak, or these subgroup findings are just statistical noise. It's a warning sign. Be cautious with subgroup results, especially if they weren't planned from the start.
Good point. Okay, now for the big one, reason number 5. That headline-grabbing claim about a 3-year decrease in aging.
Ah, yes, the most dramatic claim. The study found VD preserved about 140 base pairs BP, the little chemical units of DNA and telomere length, over 4 years. From that, they extrapolated it could mean a 3Y decrease in aging.
How on earth do you get from 140 base pairs to 3 years less aging?
This is where the author calls it a dramatic overinterpretation. That 3-year figure wasn't directly measured. They calculated it by comparing the 140 BP saved over 4 years in their study to an average rate of telomere loss seen in a different population in a different study over 10 years.
Okay, so they're mixing and matching data and making a big extrapolation.
A huge one, equating a small change in one biomarker over 4 years with slowing down the entire complex aging process by effectively 75% during that time. It's a stretch, and the author nails the inconsistency. If vitamin D really had that profound an effect, slowing aging by 3/4, you'd absolutely expect to see some reduction in age-related diseases like cancer and CVD in the main VITAL trial.
But they didn't.
They didn't. Zero effect found there. It just doesn't add up. He also points out, look, vitamin D supplement use is super common in the US, especially among older adults. If it had this massive effect, we should be seeing incredible longevity gains. But US lifespan and health span lag behind many countries like Japan, where supplement use is low, and interestingly, VD insufficiency is common.
That real-world check is powerful. Okay, final reason for skepticism, number 6.
This one's about why science is kind of moving past simple LTL as the be-all, end-all aging clock. Yes, telomeres were exciting early on, linked to the Hayflick limit on cell divisions. But LTL alone, measured in white blood cells, isn't a great proxy for overall aging.
Why not?
Because leukocyte dynamics, how many white blood cells you have, how fast they turn over, are heavily influenced by things like infections, stress, immune responses. That might not reflect what's happening with telomeres in your brain cells or heart cells or kidney cells. The source actually quotes expert groups saying there's insufficient evidence to support the clinical use of this biomarker for assessing individual biological age.
So the experts advise against using the very marker the study hyped.
Pretty much, yeah. Not for routine clinical assessment of aging anyway. He mentions researchers are now developing more complex bioage clocks using multiple markers, often tied to the 12 recognized hallmarks of aging to get a better estimate.
Sounds more sophisticated.
It is. But even then, the author adds a crucial caveat. For all these bioage clocks, it's still entirely unclear if tweaking the clock making your bioage number look younger actually translates to a longer, healthier life. Does changing the clock change your actual lifespan or health span? We just don't know yet.
Okay, wow. So summing up the skepticism, secondary analysis, questionable registration timing, biomarker of dubious clinical relevance for aging, high dropout, dodgy subgroup claims, wild extrapolation for the 3-year figure, and using a marker experts don't even recommend. That is quite a list of concerns.
It really is. It paints a very different picture from the simple VD slows aging headline.
So, given all that, why did we spend time digging into it? Why not just dismiss the hype?
Because the author's goal, and ours here, isn't just to say ignore it, it's to show you the reasoning, the evidence, the limitations, so you can make an informed choice. Maybe someone hears all this and still decides, hey, low risk, maybe a tiny chance it helps, I'll take it. Fine, as long as that decision is based on the full story.
But he brings up the opportunity cost.
Yes, and that's critical. The real risk isn't necessarily taking the supplement, assuming safe doses. The risk is putting your faith in VIT-D to slow aging, while potentially missing out on things that have much stronger evidence behind them, waiting for VIT-D to prove itself while neglecting proven strategies.
Okay, so what does he suggest is a better focus, a better way to track aging?
He champions focusing on functional aging. Simply put, that's the progressive decline of function with increasing chronological age.
Function, like how well you can actually do things, physically, mentally.
Exactly. It's tangible, it's measurable. Think fitness tests, cognitive scores, organ function tests. You can monitor it, and most importantly, you can often improve it through lifestyle.
And does he offer a specific measure, like a better clock than LTL within that functional idea?
He points to vascular age as a really promising practical proxy. Basically, how old are your blood vessels? This is driven by endothelial function, the health of your artery linings, and can be measured by looking at arterial stiffness. The gold standard measure for that is pulse wave velocity, or PWV.
PWV. Why is that better than LTL?
Because PWV is a known independent predictor of risk for the very things VD failed to prevent: cardiovascular disease and even some links to cancer risk. It directly relates to your risk of major age-related diseases. And importantly, you can measure PWV relatively easily, even at home with some devices, giving you real-time feedback on how your lifestyle choices are affecting your vascular health.
That sounds way more actionable and directly relevant to preventing the big killers.
Much more so than LTL, arguably.
So bringing it all together, based on the overwhelming evidence, what does the author point to as the single best intervention for healthy functional aging?
It's perhaps predictable, but powerful. Exercise. Specifically, he emphasizes the importance of daily high-intensity physical activity, even if it's done in short bursts.
Daily high intensity, even short bursts.
Yeah, he cites one study from the big NHANES dataset that suggested accumulating your most intense activity in bouts as short as 5 minutes might be even more effective for reducing mortality risk than spreading out moderate activity.
5 minutes of high intensity?
Yeah.
That actually sounds doable for a lot of people.
Right. And while that's just one study, he places it in the context of the absolutely massive body of evidence showing exercise is incredibly potent anti-aging medicine. It has proven benefits for preventing disease, maintaining function, improving quality of life across the board.
Okay. And Dr. Kraushaar, the author, what did he personally conclude about vitamin D supplements after doing this deep dive himself?
He stopped taking them. He mentions his own past research found some small statistical associations between vitamin D levels and blood pressure responses in athletes, but he was always skeptical about the clinical significance for regular folks.
Did he try it himself, like a self-experiment?
He did, yeah, an N-of-1 trial, as scientists call it, and he says for him, vitamin D struck out.
And he had that great analogy for vitamin D's history.
Yeah, the Charlie Brown of supplements. Always hyped up, always seems promising, but when it comes to the big, definitive trials for major outcomes, Lucy always pulls the football away. It fails to deliver the big win.
It's a vivid way to summarize his view on the evidence trail.
It is.
Okay, so let's wrap up this deep dive. We've really taken apart this vitamin D study analysis, using Dr. Kraushaar's critical look as our guide. And the main takeaway seems clear. The huge media hype about vitamin D being an anti-aging miracle, based on this specific LTL study, looks pretty shaky.
Yeah, definitely overblown. The critiques are just too substantial. The secondary nature of the analysis, the doubts about LTL's relevance here, the study's own limitations like dropout, the inflated claims, and especially vitamin D's failure in the main vital trial for preventing actual diseases like cancer and CVD.
And the alternative perspective he offers, focusing on functional aging, using markers like vascular age perhaps, and doubling down on proven strategies like high-intensity exercise, that feels like a much more solid, evidence-based path to healthy longevity?
It feels more grounded in what we know works, rather than chasing potential effects on intermediate biomarkers.
Exactly. The goal here wasn't to tell you what to do, but to equip you with the full context, the critical analysis, so you can look past those tempting headlines and make genuinely informed choices about your health journey.
Hopefully this breakdown gives you some useful tools for thinking critically about the next health craze that comes along.
And it leaves us with a final thought for you to consider, straight from the heart of this analysis. If your goal is truly a longer life, free from major disease, is chasing small changes in one specific biomarker, particularly one whose link to actual health span is uncertain the best strategy? Or does it make more sense to focus your energy on improving tangible measures of function and engaging in activities, like exercise, that have mountains of evidence showing they do prevent disease and improve quality of life?
Where does that line of thinking prompt you to put your focus?
Something to mull over. Thanks for joining us for this deep dive.